Solving exponential inequalities with logarithms. In this video, I will go through one example with two different methods. Before I go through the example, it's important to remember that for logs and exponentials, the base must be greater than 1 for the direction of the inequality to hold true. When we solve an inequality, we flip the sign when we multiply or divide both sides by a negative. This is true for any inequalities we solve, and when it comes to logs, remember that we end up with a negative value if either our b is a fraction less than 1, while our a is greater than 1, or if our a is a fraction less than 1 and our b is greater than 1. For example, log base 1/2 of 8, well, we know that 2 to the third is 8, so 1/2 to the negative third is 8, and therefore log base 1/2 of 8 is -3. Similarly, log base 8 of 1/2, we know that the cube root of 8 is 2, so we would have 8 to the 1/3 to get 2, but since we want 1 over 2, we know that this equals -1/3. So be on the lookout whenever you divide both sides by a logarithm to make sure that if you are dividing by a logarithm that is in fact negative when evaluated, you flip the inequality sign. Let's solve this inequality. I would recommend that you solve it by taking the log of both sides. So I'm going to show part B first. So we are going to take the log, and it doesn't matter what the base is, so we usually use the common log, which is log base 10. So we have log of 5 to the 2x is greater than, because that was the original inequality, log of 2 to the x plus 1. We now can use our properties of logarithms to drop down the exponent that's in the argument and make it the coefficient of the log. Because we're trying to isolate x, and I can see an x on this side and on this side, I'm going to have to distribute my x plus 1 on the right-hand side so that then I can rearrange and get all of my x's to the same side and factor them out. So I'm distributing my log of 2 to the x and to the 1. Now I need to get all of my x's on the same side. That means that I need to move this term to the other side. So I get 2x log of 5 minus x log of 2 is greater than log of 2. Since I'm trying to isolate x in the first place, I need to factor out my x, which leaves me with log of 5 minus log of 2 is greater than log of 2, with the coefficient of x out front. Now to isolate, I'm going to divide both sides by this entire expression here. So I can write it in on both sides, and I get x is greater than log of 2 over 2 log of 5 minus log of 2. Now let's pause here for a second. We just divided by this whole expression here. So we need to know, is this positive or negative? So you could type it into a calculator, 2 log of 5 minus log of 2, and you'd find that it's about positive 1.097. However, let's say we needed to do it in our head. We know that we can condense this denominator by making this part here log of 5 squared, and then we can use the fact that when we have subtraction between two logs that have the same base, we can write it as division in our argument. So it's the log of 5 squared over 2, or the log of 25 over 2. Since our base is 10, and we are trying to get to 25 over 2, we know that this is going to come out as something positive, because 10 to the first would give us 10, 10 to the second would give us 100, and this is between those, so we end up with a positive. Remember your positive and negative rules when you're figuring out if you should flip the inequality symbol. Our last step is to take this, and we could give this as our answer, but we typically want to plug this into a calculator. Be very careful to use parentheses in the right spot. So you'll need your parentheses after this 2 because you have an open log, and you'll want to put your entire denominator also in a set of parentheses. Otherwise, you will only be dividing by part of the denominator. When you do that, you will end up getting x is greater than 0.2744. We typically like to round to the nearest 10,000th. As I said before, I personally think taking the log of both sides makes more sense to do in this case. However, we also could write this expression in logarithmic form and then use our change of base. We know that these are equivalent. Log base 3 of 9 equals 2, and we could rewrite that by swaying this base to the other side. The base is still the base, so we know that that's the same as 9 equals 3 to the second. We're now going to move in the other direction, but both sides have an exponent, so we would have something more like this. There are two different ways to take this inequality here and write it in logarithmic form with a log on one side. We can write 2x is greater than log base 5 of 2 to the x plus 1 by taking the base here and making it the base of the log on the other side of the inequality, leaving this 2x where it is so that our inequality is facing the correct direction. Or we can write it the other way, where the 2 becomes the base of the log over here on the left-hand side, and we leave the x plus 1 on the right. Both of these are correct, and both of these maintain the correct direction of the logarithm. Both of these will be equally efficient to solve. So the first thing I'm going to do is I'm going to drop down my exponent on the right-hand side. So I have 2x is greater than x plus 1 log base 5 of 2. Then I'm going to follow the same steps that I did before. So I need to distribute to get x log base 5 of 2 plus log base 5 of 2. Move my x's to the same side like you saw in the previous example. And then I'm going to factor out the x. Then I divided by 2 minus log base 5 of 2. And I again would have to check to see if this is a positive or a negative statement. And it was positive. So now I need to plug this into the calculator. The reason why the other way is my preferred method is that we were using log base 10, so it was easier to plug into a calculator. When I plug this into a calculator, I need to type in this part here as log of 2 over log of 5, unless you have a calculator that can do change of base, which some of the more modern ones can. This log will be the same. So it's really making sure that all of your parentheses are in the correct place when you type it in so that you can reach your answer. X is greater than 0.2744. One thing that you can always do to check whether your inequality is facing the correct direction is simply to test the point. If we think that the critical point is 0.2744, I could test x equals 0 back in my original inequality here, and I can make sure that 0 makes a false statement since 0 is not included in my inequality. That's one way to avoid having to figure out if something is positive or negative when we divide. If you got this answer, then you should stop the video. If not, you may have made a calculator mistake, so I want to make sure that you're typing this in correctly. So we had to type in log of 2 and add the parenthesis here to close it, divided by log of 5 and add the parenthesis here to close it because it automatically puts an open one, divided by parenthesis, because we want this entire statement to be divided by, 2 minus log of 2, close that parenthesis again, divided by log of 5, close that parenthesis again, and close again because we need to account for this one. Hopefully you were able to reach this answer on your own.